G'day, I'm Mark Hoth and welcome to Swift Almanac. So core data is pretty powerful and there are some advanced features that you need to understand, some concepts you need to understand, because there are events that you need to handle basically because you're using a mobile device. So I'm going to discuss faulting, optimistic locking, merge policies and database version updates. So let's have a look. Okay, so I recorded this previously and trashed my previous recording because I thought it was really badly describing what was going on. I'm going to give it a second try. So you'll never see the first try. I don't do bloopers. But anyway, so I have I've added this load users, and that's just calling our core data code, and I have added this print statement just to get rid of the amber. These properties are never being used, use an underscore, blah, 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 blah. So what we're going to talk about is we're going to talk about faulting, we're going to talk about database version updates, and we're going to talk about staleness of data and merge policies. And really this is all to do with the architecture of a database and how you can meander your way through keeping your data up to date. Essentially, in the good old days, there was sort of the history of databases. You would have your database written to a hard drive, and then you would read it out of the hard drive and you would put it in memory. So in core data, the hard drive is called a data store, and memory is these classes that we've created here. And then along came caches, because hard drives were like really slow, and so as your hard drive was spinning, it was going past 20 records, so why just read one? Let's read in all 20 and we'll put them in a memory cache, and maybe we'll call those later and we'll get some performance out of it, right? And then we started sticking really large things in databases like images. And so there's this concept of a fault, and what a fault is it saying, well, here is our class, and we know that this is basically a record in a data table, or it's an entity in core data speak, and this entity has these attributes, and we know that what sort of the structure of the entity is, and that's what the fault is. It says, well, we've got 5 records of type person, and they've got these 5 fields: age, gender, name, person ID, and address, but we didn't actually read them in here, what these values are. We don't know what the values are. And the only time we really need the values is when they're requested specifically. So if we need to know what someone's age is, then, hey, we'll then go back to the database and say, okay, yeah, this is we need the whole record read in, and away we go. Now, faulting is actually pretty cluey. And faulting is actually part of a fetch request. So once you've done the fetch request, if you fault in one record and you've got sort descriptors, well, it knows the ones who are on the other side of the sorts, or the other side of this record. And so when one record's faulted in, it actually faults in, I don't know, 10 or 50 or 100 or however many it thinks that you're going to need. And this is this whole concept of a managed object. So if we think about it, we've got our data store on the hard drive, we've got a cache or cache, depending how you say it, on your hard drive memory. Then we've got in core data, we have a sort of a list of all of our request records as faults, which is sort of like a shell. And then finally, on our user interface, we have got all of the data that is part of the record. So we've got all of this data stored in 3, 4, maybe 5 different places, and it could change in some of those places, and then we have this problem that we need to be able to update things automatically. Now, if we were, so just with faulting, obviously the idea is to save memory. You can keep the shell, but you can throw away the data, and throwing away the data is always really nice if for instance it's a large image and you need messages. So there's a means whereby you can change these person records into faulted records, and you know, you can, I'm going to leave it to you as an exercise, but if we were to create a new file and a touch class, and let's say it's a UA table view controller, or do anything, it doesn't really matter what it is, any sort of table view, and we'll just create an edit. We get this did receive memory warning, and so dispose of resources that can be recreated. Well, that's the place to, you know, convert any records that are outside of your view field that are still in memory to faults and save some much needed memory. So that's what you would, you always see this did receive memory warning. You see every tutorial on the planet just delete it like that. But if you do deal with a lot of images through core data, that's one place where you could be saving some memory. Anyway, I'll get rid of that file. So as part of a request, oh, I've got the source code already there. So at the request, we have this return objects as false set to true, and that's the default setting. No pun intended, default setting. Return objects as false is true. If you don't have that line, if it's commented out, it's going to have the exact same effect, which means that every time you do a fetch request, you're receiving these shells, and then you're only obtaining the complete data once you are trying to display it or are making a call to these values. Now, there are some times when you want to request object false as false, and then what that is doing is loading all of the records directly into memory. And the reason you would do this is if you actually want to access every record. So for instance, if you are wanting to know the age of your population data, that would require you to sum all of the ages and then divide it by the total number of records. And so you're going to be accessing, you know, person.age recursively, or even if not recursively, iteratively. You're going to be accessing this field, and so you're going to be loading everything in. So rather than just saying, get me the faults, and then having the system go back to the data store to get all the values, it's better off just saying, no, I don't want faults, I want every data record. And so that's how you would arrange that. So so it's just simply request return objects as false equals true, and we have that one all covered. Now, the next issue that we have is we basically have data kept in two major places. One is the data store, which is, say, your hard drive, or whatever sort of permanent persistent medium you have, and the second one is this in-RAM memory user interface. And the situation can occur one way or another that allows the data in one place to change, and then we have this issue that it's not changed in the other place. And to make matters worse, you could change it in one place, and then before you've updated, you could change it in the store, but before you've changed it in memory, then you might try and then save it in memory, and then you get this what's called a lock, where basically you're overriding data that you didn't know was there. So there are well, there's two possibilities and several ways that this could occur, but essentially the data on the store could be updated first, and the data in the memory could be updated first. So in our situation, or in our example, what we'll say is that in memory we've got our interface, so we can change the data there, and in on our data store side, we've got a background context that's running, and it's sucking down new data continuously from a website server somewhere. So for instance, once an hour it's going off to a web server saying, hey, give me all the data that's there, and it's sucking it all down, and it's updating the your iPhone. So our main context, this persistent container context, that context is our user interface side, and there's a parameter called merge policy, and there's this enum ns merge policy, and .error is the default. And what it says is if there is a conflict, if memory and the store are different, then return an error with all the conflicts. And that's returned as an array, probably an array of two things, and then you can display a user interface and say, hey user, did you mean this or did you mean that? And the user can select which one, and you can save that, and you can say bang, that's the one we're going with. So that's the default error, and there are some alternatives which are all automatic. If you select these, then the database will just do what it is told. So if you select rollback, then there's no interface, there's no return when you do a save, there's no value returned in a save. It will just roll back, it will ignore the memory state, and it will reread the data in from the data store and update your managed object. That's why it's managed. The other alternative is the overwrite, which basically pushes what you've got in memory and whacks that into the stored version, and it moves in the entire object. So if you've got a person, it's going to completely overwrite that person record. And then you have these two other options, which are merge by property object trump and merge by property store trump, and these are basically similar to overwrite, except it's only by the property. So if you merging by property object trump, then it prefers the stored version to the in-memory version, but it only updates properties that have changed. And if you have merged by property store trump, then it prefers the in-memory versions to the stored versions, and again, only the properties. Now, if you've got something in memory, you how do you know if it's how do you know if there's a change? And so in the database world, there's something called optimistic locking, and it's called optimistic locking because in most cases, once you read it from the store, and you normally have it for a small period of time in memory, you make a change and you send it back. Most times to a database, it's only a read access, and so it's not going to change anyway. So it's very unlikely for the majority of instances that there'll be this change, that there'll be this conflict, and so you don't need to worry about it. So what happens with optimistic locking is when you read the information into memory, it keeps a copy it basically keeps a copy of or a snapshot of the record as it was when you read it in. And then when you say, hey, I'm going to save this, it compares the snapshot that it took with the stored version, and it says, hey, are you different? And they're not, so it just saves it. But if it is, that's when it starts looking at this merge policy to figure out what it's going to do with these records. What you can do with these merge policies is they can be different depending on where your context is running. So if in the example I gave, we've got a user interface, then the default context of .error works pretty well, because you can say, hey, we've got an error, there's been an update while you've been, making changes. Do you want the new update, or do you want to override it with what you've done? Yes or no, and then you can save it. But here in the background context, we just might want to say, well, look, if we've got something from head office, then it doesn't really matter what Joe the employee thinks. The legal department says this is the new rules, so let's override it because that's really important. And so you can have different merge policies applying to different contexts, and of course the contexts are all dealing with the same data store. Now the next issue is we have managed objects, but our data store is not managed. So if our background task makes a change, and we've got something in memory, how do we update what's going on in memory? Now there's a simple way and there's a more complex way. So the more complex way is to use Notification Manager, and I'm not going to show you how to do that. And the reason that it's really not that important is because, generally speaking, you're not going to be updating information continuously from data stores and from external sites. So there's really no, well, it's quite difficult to justify writing these notifications because it's such a rare occurrence. And there's another more simpler way of doing that, and that is called staleness. So staleness is the length of time that you're prepared to believe that the copy of the copy of the data records you have in memory still matches the copy of the data records written to your data store. Okay, so if, for instance, there is no task which is updating these the data store from an external source, then your staleness can be the default, which is negative, and which actually means infinite staleness, which means we will always use the cached copy after the initial fetch. So what this is saying is, when we fetch the records, they're going to be cached into memory, and whenever we scroll our collection view up and down, we're just going to access the cache. We're never going to check the data store to see if it's changed. Okay. Now, if we have a value, and that's the default. The default is just a negative value. It could be, it doesn't matter what it is. It could be -1, for instance. All right. Now, if you set the default value, the staleness interval, to 0, that means there is no staleness. That means that we will always issue a new fetch command, and we will always ignore the cache. So if we've got, say, 10 records on this screen and we scroll up, we're not going to look at the cache. We're just going to go, hey, give me another look. Now you can see that's going to be pretty inefficient, right? So you're probably not going to use this unless your database is like changing continuously and rapidly, okay? And then the third possibility is that this is a positive value, and this positive value, it's like it's an NS time interval, so it's a sort of a float or double. But in any event, it's the number of seconds. So we've got 300 seconds, which is 5 minutes, of course. then that's the number of seconds that we use a cached version, and then we will be using a then after those 300 seconds have passed, if we move around, if we actually need to, then we'll call a fetch. So and basically this staleness interval is going to map quite heavily with this background context and how often you are checking the background to update your information. So if you are updating the information on an hourly basis, having this set at 5 minutes is really not going to help, right? It really should be set at 12 times that, which is 3600. And then that way we would look at the cached version, but then in an hour's time, we would be checking to see, you know, if this has changed, right? So the two things, and well, of course, you're still going to have a period of time which will be less than an hour, where the data store could still be different to the fetched or the cached information, and you can figure out exactly what you want to do to prevent that, depending on how big the data is, or the data difference is, and the like. So, but in any event, what you need to understand is that if these change, you're still going to have this merge policy, which is going to inform you about the error. This is more, or sorry, the staleness interview is just more about keeping the data that's displayed up to date. So then there's only one more thing that can possibly go wrong, and it's not really that difficult to achieve, but it could be that you've had a successful version 1 of your product, and now you're looking at version 2, but in version 2 you need to make a change to your data model. So in our data model, for instance, I'll just go back to here. Okay, so we started off with our final data model, and as I said, I've done this previously, so I've got some other examples in there. But essentially what you would want to do is you've got your data model, you go up to the editor and you go add model version, and then do you want to base it on final, or do you want to base it on each of the other ones that we've done? You click finish, and it creates a new version of the data model. Now, in the second data model, what I did is I added an address ID, which was UUID, and in the third data model, I added Galaxy. It wasn't enough for us to know which country we're in. I need to know which galaxy we're in, and of course I've forgotten to mention planets. So in final 4 under address, I'm just going to create a new attribute, which I'm going to call the planet, so that you know, everything is working fine. And then when you release your application, you're here on this final, and you go over to model version, and you go, no, we're not using final, we're using final 4 as our current version. Now, what happens is, once you release the new application, on startup, when your little app delegate's going through here and going, hey, get me the persistent container, and let me know what's you know, returning this container, it's going to see, hey, the data model's changed, and in LightWeight data migration, the operating system does these things for you, and it'll look at final 3, and it'll say, oh, okay, well, final 3 didn't have a planet field, so I'm going to take all this data out of final 3 and create it in final 4, and it's going to add a planet field. Now, planet is optional, so it doesn't need to have any default values or anything like that, but if you want to give it a default value, then every record that gets imported, it's going to have a default value put in there, and you can put validations and all the rest of it. Okay, so LightWeight is pretty good if you're just like adding fields or adding new tables, or if you want to change the name of something, that's okay. Not so good, I don't think you can change the data type. I could be wrong on that. And it doesn't like it if you are trying to change relationships around too much in a sort of a parent-child type situation. But for small changes and new tables, and if you're adding or just changing, that tends to work really well. The good thing about it is if someone's got version 1 of your application, but they missed versions 2 and 3, and then they, come back and they go, oh, version 4 is so much better, I'm going to get version 4. Well, when they load version 4 in, it's going to look at their data model and go, oh, you've only got final, that's 3 versions ago, but it's still going to go from final to final 2, and then from final 2 to final 3, and then from final 3 to final 4. It's all going to happen in the background. It's all going to be really nice and nifty. It's an awesome feature, and it happens automatically. Now you can programmatically check with about 5 or 6 lines of code that this is going to be successful, but that's sort of pointless because you'll be testing beforehand, and you'll know when you run your application whether or not it crashes or not in testing, to know whether or not you need to use the hard weight or the heavyweight migration method. But apart from that, it's pretty straightforward. If you look up here, so from our app delegate, we normally just go straight from, we just go straight from the app delegate to the context by going through the persistent container to get our context. But here what I've done is I've said, hey, give us the container, and then the container has also got this properties persistent store descriptions. You'll note the S, it's an array. Now on your iPhone, you're probably not going to have one store, but on a Mac there could be multiple stores. But in any event, I'm printing out these 2 values should migrate the store automatically, and we should infer the mapping mode automatically. Now these both default to yes, which means you don't need to do anything apart from create this new data model and make the changes, which is really, really nifty. Now we called, there it is. So we've got true and true. So they're by default set to true, don't need to do anything about the data stores. That final line there is this print name, age, gender ID that I added from last time. The really important thing to remember is you do not change the original data model. You change the one that you have created. And it's actually quite simple to be, even though this one's got a tick on it, to be, on selecting the wrong file and just go, oh, I'm going to add an attribute, or oh, I'm going to add a relationship, etc., and you've created the wrong thing, and that will completely screw your data migration. And that's about it for core data. Well, that's all for core data for now. I will be doing a future tutorial on core data and collection views, but it'll be in 2018. Have a great Thanksgiving if you're in the States, and if you've got any questions about this tutorial, then please leave a comment below or hit me up on Twitter @SwiftAlmanac. Please subscribe to the channel, it's free, like it as well, and check out our website at www.swiftalmanac.com. Thanks for watching, and we will see you next time. Cheers.